50 of you not here yet. Let's wait for another 1-2 minutes. Okay, let's start. Now, I just generate the link that which you all join now is for the replacement today only. That means when we back to our normal lecture, as well as when we go back to campus, we use back the original, remember the first thing that I generated for the every week one, use back the same link. Only for today replacement, I generate another new link because I don't want to generate another Google Calendar. Okay, so I hope everyone remember next week we go back to the first link that I share with all of you. All right. Okay. Now, so this is the replacement for 31st of December, which is for the next another Monday lah. So that is for the Chinese New Year Eve, if not mistaken. I hope everyone take note so you can have a longer break, and don't forget to come back on the next following week. All right. Any questions from anyone before I continue to the screen there? Okay, so we will start. I will do the video recording. The first video recording I posted in the GC. I hope everyone already access. Anyone cannot access, you let me know. So I will do the video recording first. Now, I may not use 2 hours for today because this is Saturday, right? I know suppose some of you want to follow your parents for other activities or shopping, so I may just I may not use 2 hours fully, right? And we cover as much as we can, so that for the next tutorial, when you start with your tutors, you all can proceed to do your tutorial 1 and tutorial 2 lah. All right, so we already recorded now. Let's go back to my screen. Now, last first week, right, of lecture, I have discovered a lot of concept with everyone. From the beginning of why we learn statistics, okay, the purpose of learning statistics, and so on. And then we discuss about type of data. It can be quantitative, it can be qualitative, and then quantitative data can be spread out into 2 more. Okay, categorized into discrete and continuous again. And I hope you also remember discrete means the data cannot be measured in round number, or only in integer exact number. And then some data, some variable can be measured in point form, right? For example, height, weight, and so on. So look around yourself, everybody, look around yourself. What are the variables that around you that you can measure in point form? And also, what are the things around you, everyone? After this, you take a look at your house, your office, your campus. What are the things must be measured in point form, and what are the things must be measured in integer? That means this cannot be point form. So look around you. Of course, every time when we deal with variable, the values can be in discrete and continuous. So this is very important. Because when we do our data presentation, remember, we have the group and ungroup data. Remember, for group data, we have the table and then the frequency. For raw data, no table, no frequency. So I already shared with you some examples, right? I hope you've gone through your revisions. And you can see that group data, as I mentioned, there is a table to represent each classes with the respective frequency. And this must not be what we call it overlapping. Cannot be overlapping. That's why for discrete data, you can see that this first class, the upper limit, there's a gap with the second class lower limit. Remember, I say this is 19 and this is 20, there is a gap by 1. So this is called gap. Remember, gap. So we need to close the gap for discrete data. And then there's no double counting. So when you do the question later on, remember, if you have a gap, you must close the gap, especially when we talk about this tree example. So for those inclusive type 1, there's a gap, right? You need to plus minus 0.5 because there's a gap here, you see? 9, 10, 19, 20, 29, 30, there is gap by 1. So you need to plus 0.5 at the upper limit, and then lower limit, you need to minus 0.5. And then you get the, we call this boundary, the actual boundary. So these are very common question may be asked. So take note, you have to close the gap. Whereas for continuous data, you can ignore the less than sign, and then you can just put the dash. You can see here, no gap, 10, 10, 20, 20, and so on. So this is the typical for continuous. This one is for mainly discrete. Okay, and the third type is this open-ended. You must know what's the meaning below and above. So I already share with you one or two examples how we define the value for the if you have a below and above words. You must know from when to when. What is your lower and what's your upper boundary? Okay. All right. So I hope everyone have gone through all this again, and then we managed to go through another 1 and 2 example here, right? From ungroup data, you change to group data in the table form. So I believe everybody already understand. So this is about books. Books is a discrete law. So that's why you have to start from the lowest, which is 10, right? The highest is 100. You look from the data here. So your first class must start from 10 to 29. You cannot have 30 because your next class start from 30 to 49. Why it's not 30? Because I told you, you cannot have overlap and cannot be double count. If you put 30 here, right, everyone? This one also 30. This one also 30. Then if I have data which is 30, right? So I ask you, you want to put in this first class or you want to put in the second class? That's why I ask you, why not 30? Because cannot overlap. So you cannot put 30 here. You must put 29. Oh, this one 49, cannot put 50, and so on. Cannot overlap. But when you want to do the calculations and draw histogram and so on, you cannot leave it like that because this is a gap. Remember, this is a gap. You need to close the gap. So again, you plus minus 0.5 become 9.5 to 29.5, then 29.5 to 49.5, right? I see you close the gap already. And then you can proceed to do your graph and also calculation. Okay? And somehow you want to find the class size, you take the upper boundary minus the lower boundary. So you should take 29.5 minus 9.5, which is 20. If you take 29 minus 10, which is 19, it's wrong. See, I put here wrong. Okay, everyone? Hopefully that you pay attention on the gap and no gap, especially for discrete data. Any questions? Anyone have any problem?
No.
Okay, so if you have, you just use a mic to stop me. Otherwise, I just presume everybody so far so good. And another example, which is continuous, we talk about rainfall. Right? Rainfall is a point form. So again, we transform all this group data to group data using table again. So you can see the lowest rainfall and the highest rainfall. So you start from 19 now, because 19.22 is the lowest one here. Okay, and then the highest is the 3.01. So you start from first class 19. Make sure 19 is inclusive of 19.22. Oh, okay. So you reach until 22. Let's say the class size is set to 3. So 19 plus 3 is 22. Then the second class start from 22 to 25. Now you can do like this because continuous data. Remember the first example. This is for the continuous one. You can put less than, because again we don't want to overlap. So you put 19 to less than 22. In other words, less than 22 here means what? 21.9999. It won't touch 22 exactly. That's why when you go to second class, you can start from exactly 22. So if I have data which is exactly 22, I want to put first class or second class? I have to put at the second class, correct or not? Because 22 is exactly 4 in the second class. I cannot put first class because my first class maximum is 21.999. I cannot touch 22 because it's less than. So again, this is non-overlap. You all must remember this. So the next class, third class, and so on follow. +3, +3, +3. But when you want to build the actual boundary, upper and lower boundary, again, you can ignore the less than sign. You can throw away. Just put the dash like that. It's okay for continuous data. Just remind yourself that the first class, actually when you write 22, but you know the concept is actually less than 22. You have to remember lah. Okay. People will ask why in that case we still throw away the less than, because people's mind always don't want to see the less than. The lesser the better, so they throw away. But they remember it's less than 22. Even though the first class is you write 19 to 22. Okay. So for the rest of the class, remember that. Okay. So I believe everybody have taken this note down, and then the class limits, class boundary, as I mentioned, size class, we take upper minus lower. Okay, the next one, class midpoint, the middle point. How to find the middle point? You can take the lower class limit plus the upper divided by 2, or you can take the lower boundary plus the upper boundary divided by 2. You all know the difference between limit and boundary, right? These are all limit. This is class limit. This is called class boundary. For continuous, not much different now. Okay, you can see that all the same one. But for discrete data like this is your class limit. Your class limit. For this one, after your plus minus 0.5, this is your class boundary. That's why when you want to find the class size, you must take upper boundary, not the upper limit. If you take upper limit minus the lower limit, you get 19, right? Right? That's why for class size for discrete, you must take upper boundary minus the lower boundary, which is after your plus minus 0.5. Okay? This is what is already stated here. Boundary minus boundary, not limit. But you want to find the midpoint? Yes, you can use limit or you can use boundary. But people usually use boundary. Stick to one boundary, easier to remember. Okay, so this is some of the example which can show you the class here. If there's a gap, you close the gap. So you see, this is class limit. You change your class boundary plus minus 0.5. You close the gap already. And then you find the class size. You take the upper minus the lower boundary. You get all the same size, 20. And then to find the class mark, you take the upper plus lower boundary. You divide by 2. You get 19.5, 39.5, and so on. Then you can see here, 19.5 to 39.5, how much is the difference? 20, right? This one also 20. So you can actually find the class size by taking the class mark of second class minus the class mark of the first class. Also can get 20. Everyone take note. Okay, now this is a diagram to show that the class mark, class limit, and the class boundary for discrete data. For this case, you see your class limit is 9 to 29, or 10 to 29, sorry. But the class boundary is 9.5 to 29.5. See or not? The class limit is from 10 to 29, but for class boundary, you need to minus 0.5. So 10 become 9.5, and then 29 become 29.5. So your boundary become bigger than the limit. Same for your second class and third class and so on. But if you have continuous data, this example, right? Same thing. Okay, class size is upper minus lower. The class mark is upper plus lower divided by 2. So you get all this. And then if you look at the diagram, the class limit, let's say the first one is 19 to 22. And the class boundary is also 19 to 22. You see, they are the same one. You don't need to plus minus 0.5 because there's no gap there. The changes is very small, 21.999. So might as well you ignore it and you assume it's almost the same. So no need to plus minus 0.5. Second class, third class also the same. Can okay. Can we start with the so Chen Kim Shen, you asked me what's the difference between class limit and class boundary. Have I explained to everyone, right? I hope you can understand now the difference between class limit and class boundary. Any more questions? Okay, so let's start. Have you bought the graph paper? I asked you to buy graph paper there. Well, buy lah. You can buy one book and then share with your friends or whatever. Okay, histogram. I'm sure you all know what is histogram, or you heard before like this. Histogram basically is like a bar, like a building. Histogram, when you draw histogram, usually you draw from here lah. Okay, a lot of people like to draw from the left hand side, touching here. So they take it as the safest 0. Then they draw histogram, something like this, and so on. Okay, so basically it's a bar, like a building, draw for each class. Each class means from 0 to 9, 9 to 19, and so on. The class limit. And then the area of each bar is proportionate to the class frequency. So how tall, how high is the bar of histogram depends on the frequency. Usually your Y here will be your frequency. Okay, this will measure the area of each bar because this is proportionate. Okay, the x-axis will either show the class boundary. Remember, the x is usually the class boundary. Remember, depends on discrete or continuous the class boundary. So for discrete one, you need to plus minus 0.5. For continuous ones, no need. Okay, usually we take class boundary or the midpoint also can, but seldom people use midpoint. Confusing. So my suggestion is everything you remember class boundary easier. Even you draw histogram, you want to calculate the class size, everything take class boundary easier to remember. Use one for all. Okay, now. The y-axis will be showing the frequency, as I mentioned just now. Okay? Alright, now, when you draw histogram, everybody remember Frequency got, histogram got two types. One is same size. Same size means, remember the class size is all same one. For example, you see this one. What's the class size? All same, 333. This one also all same, 20, 20, 20. But sometimes you don't have a class size all same. Okay, so I will write here. You can have same size. You also can have not same size. Let's see, got example not same size or not. Let's look at one example. This one not same size. You see, 0 to 99, 100 to 199, 200 to 299, and so on, right? So the class size here is 100, 100, 100. But the last two class here is 200, 200. This is not same size. What should we do? I tell you later. This one is the same size here. Yes, all these are same size. 19, 19, 19, 19, which is 20 lah. 20. All these are same size. So you see, when you draw a histogram, you have to be careful whether it's same size or not same size. So you see, for frequency distribution with equal class size, or we call it same class size, the height of each bar is drawn proportionate to the actual frequency. So for equal class size one, no issue. Whatever frequency we have or given, then you just draw in the graph paper, follow the frequency. You have to level your graph later on. Everybody must know how to learn to scale your graph. Okay, you know what's called scale, right? Scaling, for example, how many cm for how many units and so on. Everyone must know that. You have to learn so that your graph is not too big or not too small. Okay, and the width of each class, each bar extend from the lower to the upper. This is what I mean here. The class boundary is representing each class from the first one to the last class, the lower to the upper boundary. Okay, all right, we show one example after this. Okay, now for the unequal, everyone, you highlight this unequal, not same size. This one not direct. We need to do what? Adjustment of frequency. Everybody highlight this. Adjustment of frequency for the class that is not same size. Okay, highlight this. Now, we need to build one formula. We need to calculate one formula, which is the adjusted frequency. It's given by the common class size. Remember formula? Common class size multiply the frequency given, divided by the class size, which is you follow the question, whatever they have, right? You calculate, that's the given class size. Okay, so you're going to look at two examples now. The first example is for same size. I write down here for this one, equal size. You can see here. Okay, and the second example I show you just now, this one is not same size. We have to do the adjusted frequency. I will show you later. Let's look at the same size first. Now, construct histogram for this frequency distribution of the books. Again, books is what? Discrete. Borrow in the year by 30 students. Similar to the example here. Remember this example? Similar to this example. Okay, 10 to 29, 30 to 49. This is your frequency. We use the same example, easier. This is your frequency. Okay, now total is 30. Total of frequency. Remember this symbol? Okay, so remember how we know they are same size? You want to check? Go ahead. This is your class limit. But you need to change your what? Class boundary. How to change the class boundary? Plus minus 0.5 because this is a gap. So I minus 0.5. This one become 29.5. Second class also do the same as I showed you before. So you can see that there is no more gap. And what is the class size? You can write down here, what is the class size? Upper minus lower boundary. Minus 20, 20, 20, 20. All these are confirmed same size. So when you want to draw histogram, no issue. You just draw the frequency for the y-axis, and then the x-axis is your each class boundary from the lower to the upper. So let's look at the answer here. Title: histogram of number of books borrowed per year. Make sure you write your title. Write your title. Reminder: a lot of people never write the title. Minus mark. You don't get the 1 mark or half mark there. Okay, your y-axis always your frequency, no? Number of students. Then your class boundary is your x-axis. So as I mentioned, class boundary will be your starting from your first class 9.5 to 29.5 here. Now you may ask me, can I start 9.5 here with 0? The answer is yes. Many of you, they thought that 9.5 because here is 0 mark, so they start all this empty, and then they start from here 9.5, then next 29.5. So here all empty. Don't do that. Don't do that. You waste your space because your graph paper not very big. So you need to squeeze all this 9.5 squeeze to same level as 0. Start from here. Can. Anyone want to ask me any question before I go on? No. I hope I'm not too fast. So again, 9.5 you don't start. Let's say 0. This one 1.5, 2.5 until 9.5. All is empty. Don't waste it. Squeeze all to the front. Okay. So 9.5 then to 9.5 because this is your first class 9.5 to 10.5. Your frequency is 8. So you draw here 0, 1, 2, 3, 4, 5, 6, 7, and 9. 8 means here. This is your first class. See or not? Second thing I would like to highlight is the scale. Remember I mentioned the scale. Here maybe you use 2 cm. You know 1 cm, 2 cm, right? How big is that, right? Use your ruler. Okay, 2 cm for maybe here is how much? 20 centimeter, 20 unit. The size is 20. So make sure your scale is not too big. Can fit into 109.5. If you use too big cm, then your graph cannot fit in the x-axis, the class boundary. Same for your y. What is the highest frequency? 8, right? So you may use 1 cm. If you think 1 cm too small, then you take 2 cm. 2 cm for 1 unit. So you start from 0, 1, 2, 3, 4, up to 9. No? If you think 2 cm too small, then you use 5 cm for 1 unit also can. But 5 cm is very big already. So make sure your graph is not too big. Otherwise you cannot fit in the highest frequency there. So everyone, take note of your scale. You have to learn how to choose the cm to represent the unit. Make sure your graph not too big and not too small. You find that some students draw the graph so small, like a small toy at the corner of the graph. Can't even see anything, or 1/4 of the page. Very hard to see. if you can maximize your graph. Just nice fit in. Any questions? You want to put 1 cm so can, up to you. But I think the graph will be very short. So the next class is 29.5 to 49.5. The next class. So it's 7. So you see, from here to here you draw 7. No? The next class is 69.49 to 69.5 is 4. And do until the last one. See, here all 20, 20, 20, 20. You cannot skip the class boundary. I noticed that some people, they put here 9.5 to 20.5, 20 cm, 20 unit. After that, straight away to 89.5 or 100, 09.1. Cannot. 20, 20, 20, 20, 20. That's why you use here 2 cm, every 2 cm, 20 unit, 20 unit, 20 unit. And this is all same size, ma. So you must have 20, 20, 20. Any questions for this same size histogram? Okay, now let's look at the unequal. Next example. Sorry, this one is still same size, sorry. This is about the rainfall. Same example from the above for the month of December. 19 to 22, 22 to less than 25. So this is your class limit. Your class boundary, as I mentioned, you can actually ignore the less than symbol because the less than is very, very small. We can ignore the less than symbol. And then the class size here, still the same, 3, 3, 3, 3, right? You minus from upper minus the lower. So still same size. And then when you draw your histogram, again, this is the continuous. So whether it's discrete or continuous, you see this is discrete, looks like this is continuous for rainfall, doesn't matter. As long as same size, you just draw the x-axis for the class boundary. So 19 to 22 first class, the frequency is 4. Then you draw 4 here. Then 22 to 25, second class, the frequency is 10 days. So you draw 10 days here, and the rest until the last class. So here you may use 2 cm if you want to have a clear bar, the size. So you maybe take 2 cm for 3 unit, or you want to take 3 cm for 3 unit also can. And then for this one, frequency, the highest is what? 12. So you must make sure you can draw the frequency up to the highest 12. Then you give one allowance to 14. So this is 2, 4, 6, 8. You can use 2 cm for 2 unit, or you want to use 1 cm for 2 unit also can, or 1 cm for 1 unit also can. But if you use 1 cm for 1 unit, I think this one graph can be very, very tall. So make sure you can fit in 12 because 12 is the highest. Everyone. So you have to buy the graph paper, everybody. You need to draw actual on the graph to make sure you train yourself to write the title, label the class boundary with the unit, the y-axis with the frequency, with the also the title, the scale, and then draw the histogram exactly. So both of these examples are giving us the same size. One is for discrete and the other one is for continuous. It doesn't matter. As long as same size, you just draw accordingly. Can? So when you do your tutorial 1 and 2, make sure you know first thing, whether the size are same. Second thing, you have to check other things. If it's not same size, you have to adjust the frequency, which we are going to do now. Okay, ready? So we're going to do for, if it's not same size, we have to adjust the frequency. Highlight already, right? Okay, so let's read the question here. Construct a histogram. This is about the sales of 46 branches for a company in 1 week. So you can see that the sales between 0 to 99, there are actually 10 branches close the sales. 18 branches close the sales from 100 to 199. 8, 6, and 4 branches only have the sales between 500 to 699. So you total up all these branches will be 46. Correct? This is your frequency. Any questions? Okay, now this is your sales in units. Can you tell me what's units? Continuous or discrete? Anybody want to share your thought? When you say the units, is it discrete or continuous? Let's say you buy handphone, right? You buy 1 unit of handphone. You want buy 10 unit of handphone, or you want to buy machine, 1 unit of machine, 6 unit of machine. So unit is usually discrete. That's why, what do you see here? There is a gap. Can you see the gap? So this is your class limit. You need to change your class boundary. So again, this one become minus and plus 0.5. And this is what you see here. Up to the last class, 499.5 to 699.5. So this is your class limit. This is your class boundary. Okay, so this is your frequency. Your class size here, all these are 100 minus upper minus lower, 100, 100, 100. But you see the last 2 class here, 499 minus 299 is 200, 200. So these two are different classes. Everyone clear or not? Everyone clear? Even one of the class, different class, the rest same class, also consider not equal size. It must be all same one. Even one not same size, no? So what do you need to do now? This is your frequency, right? So you cannot use this really. You have to create one more called adjusted frequency. Your frequency is here. So you need to build one more column called adjusted frequency to calculate for these two. The first 3, everyone. The first 3, okay, you see our formula for adjusted frequency. Everyone, you look at here. We have what? Common class size times given frequency multiply the size which is given. Now, what's the meaning common class size? We set the common class size. Now, you can copy down. You set the common class size follow majority. Some people say like that, follow the majority. So you set the common class, follow the majority. Oh, okay. Now back to this one. What is the majority of the class size? 100, 100, 100, right? 300. Majority is what? 100. So you set the common class as 100. See? Common class is 100. Okay, everyone. Okay, you times the given frequency divided by the size. Okay, so that's adjusted. So now you look at the first 3 here, 1, 2, 3. The adjusted and the frequency are the same one. Can you see or not? 10, still 10. 18, still 18. 8 still 8. You know why they are still the same? Because the class size is the same as common class. So let's say I use this formula, I show you all one. Let's say the 10 frequency is 10 at times 100 common class. Remember, I set as 100. I divide by the class size, which is also 100. So 100 divided by 100 become 1, no? 1 times 10. That's why my adjusted is still 10. So for the 18, you still have 18 also, because the class size and the common class cancel off, become 1. 8 also become 8, because again the class size is still the same as the common class, cancel off, become 1. Everyone understand? So in future, whenever you see the class size and the common class are same, your frequency and the adjusted frequency is the same. But the last two here, careful. The class size is 200, double of 100, right? 2 times. So what happened to your adjusted frequency? 6 become 3. Divide by 2, right? Why divide by 2? Because the class size double. You don't believe it? Okay, fine. Let's use this formula. Adjusted frequency for 6. So the common class is 100. The class size here is 200. Now it's no more 100. It's what? 200. So I will take 100 divided by 200 times the frequency given is 6. So 100 divided by 200 is half. Half times 6 is 3. So 4 will become 2. Same thing. 100 and 200 become half. Half times 4 is 2. Can everyone? Anyone cannot follow? Am I too fast? Okay, so after you have get this part here, adjusted frequency. Now, when you want to draw histogram, for not equal size, you have to use what? Use the adjusted frequency. So we are going to use this and not this to draw the histogram. That's why you see my title now is adjusted frequency. Before this we use frequency, right? Same size. Now we don't use frequency, we use adjusted frequency. So again, your title shows the sales for 46 branches of a company in 1 week. This is your class boundary. Now you see your class boundary, even though your first class start from negative, right? 0.5 to 99.5. Don't worry, even though you see negative here, you will wonder, should I move to the left-hand side? Usually negative, okay, everyone, you see your X and Y plane, right? Negative 0.5 by right should be here, right? Negative, this side. So you will ask, should I draw here to 99.5? Should I draw like that? Let's say this is 10. No need. It looks very weird. Negative 0.5. So don't worry, you push negative 0.5 to 0 also. Just now I show you from here, push to the 0, right? Left-hand side also can push to the 0. Everything start from y-axis here. Can. So here, make sure you write negative 0.5 to 99.5. This is your first class. With the adjusted frequency, 10. Then next class, 99.5 to 199.5 is 18. Okay, next class, 199 to 299 is 8. Now you can see these three are same size, right? 100, 100, 100. But the next one, 299 to 499 is 200, double. So the adjusted frequency is 3. Here, 2 and 4, right, is 3. See, factor wider, but shorter, 6 become 3. And the last one, 499 to 699, also double. So the adjuster is 2. So you can see these 2 are better than the other 3. This is what we want to see. Again, your scale 2 cm or 1 cm, up to you. Make sure your graph can fit in. So I suggest you can put 2 cm for 100 unit. If it's too big, then you use 1 cm. For your adjusted frequency, you want to use 222, can. So maybe you want to use 2 cm for 2 unit or 1 cm for 2 unit also can. If you think 2 cm is too big, cannot fit in, then you use 1 cm or maybe 1 cm. 1 cm for 2 unit. Okay, everyone? So don't worry about the negative. You can push to the 0 also. So don't waste your space left and right. Squeeze everything to the front. Okay, now everybody. So I spent about half an hour here. I hope everybody already clear. When we draw histogram, you have to take note whether it's same size or not same size, and label your graph. Y-axis, x-axis, and the title. Can? All right. Now, I've covered everything from the discrete data, continuous data, and then how we determine the class size, how we determine the class boundary, if it's a gap, close the gap. Then for continuous, no need to close the gap. We just use back the class limit as the class boundary, and then how to find the class mark, and so on. Okay. So the next thing is I want to spend some time here to discuss with you about skewness. So after you draw the histogram, then you will wonder why we draw the histogram. Because we are going to look at the shape of the frequency distribution, which is actually in the image of histogram. After you draw the histogram, you can see the shape of the frequency distribution. Now there are 3 types of skewness. Look at the word skewness, everyone. You highlight this word. Actually, what is skewness? Skewness is actually look at the pattern of, or we call it trend, or we call it shape of the frequency distribution. So you look at, when you draw your histogram, if you find that your histogram, the pattern is like this is your Y or frequency, right? This is your class boundary, x-axis. So if you see that your histogram is like the highest, go down to the lowest, we call it peak. Peak means the highest. Peak of the histogram lies to the left of the center of the distribution. Now, center of distribution is here. This is your center of distribution. If you look at here, this is the peak. Peak means peak mountain means the highest one. Is at the left. This is left hand side, This is right, everyone. Left and right. This is your center. The peak is at the left. So when you have this scenario, we call this positive skewness. Or we call this right skew. Some textbook, they call it right skew. If after you draw the histogram, you find that your histogram pattern is like this, slowly go up. So again, this is your center of the distribution. And then the peak, which is here, lies to the right of the center. This is your center. This is right hand side, right? This is left. So your peak is at the right of the center. Then you will call this negative skew, or you can say this is left skew. And the third scenario, after you draw the histogram, this time you see your histogram goes up, and then at the peak here, and then it go down again, and then you can see the peak of the histogram lies at the center. This is the center, right? And then the peak is about the same as the center. So the left and the right is balanced. This is called what? Symmetry or no skew. Symmetry means no skew. You all know what's called symmetry, right? Same, left and right both are same. So we call it not skew. Okay, everybody? When we come to chapter 4, chapter 5 also, I will come back to this one again. Histogram, skewness, positive, negative, and symmetry. Oh, everyone. So chapter 4, 5, I will come back to this one. So everybody take note of this skewness. This is very important because when we do the analysis of data, remember first week I mentioned that first lecture, when we collect the data, we want to analyze the data. One of the measurement or one of the area that we want to comment about our data is skewness of. Okay, so at the moment, you all just remember there are three types: positive, negative, and symmetry. How we know it's positive, negative? We look at the histogram pattern. Okay, can all right. Now, the next thing that after we draw histogram, yes.
Sir, can you repeat the skewness again about the left and right?
Oh, okay. Positive skewness means the peak here is at the left of the center. This is your center of distribution from the remember this is your first class up to the last class, right? Like this you have drawn already first class up to the last class, first class up to the last class as usual. So when you look at the center is here, and then you always look at the peak. The peak is at the left hand side of the center, then it is positive skew. Look at the peak, the highest one. If the second scenario, your center is here, and then the peak here is at the right of the center, which means your data is negative skew. Okay, look at the peak, the highest one. And if your peak one is at the center, similar to your center of the distribution, here you see. So that means this side and this side is very balanced. So you can say this is symmetry, no skew. Symmetry means the left and the right are very quite balanced. Okay, now let's look at some of the histogram that you have drawn here. Everyone, you have drawn a few histogram, right? The first one is this one. Okay, so based on this histogram, tell me, is it skew, positive or negative or symmetry? You see the peak is here, right? This is the highest compared to all the 5 here. So the center is about 300 here over here. 699 is about 700 700. So it's about center is about here 350. So the peak is here, which is at the left, right? Right. So this one is called what? Positive skew, like this. Left positive skew. Okay. Anyone don't understand? And then you look at this.
Thank you, sir.
Welcome. If you look at this one, another graph that we have drawn just now for the rainfall. So where is the center? 34, 19. So it's about 15, right? The center is about 7 here, about 26. This is the center. Okay, center. And then the peak is also here, right? This is the tallest part, compare all to 5. So the center is almost here also. So you see, it's almost symmetry. Okay, everybody. If you look at this one, this one is a bit hardly to comment now. So what is your center? 100, half is 50 here. The center is here, but the highest is here, right? And then you can see the histogram is not much different, right? It's a bit weird lah, I would say that. So you can see that I would say that the data here not strong enough, not too many data. So you see the histogram also different from this shape. And this one, oh, very hard to comment. I mean, you want to comment, you still can say it's positive skew because the center is here and the peak is at the left. Definitely cannot be symmetry because here is going down, the highest is here. So the center is here. So we can say that this is slightly, I can use the word slightly, means what? A little bit positive skew. Because the center here, the highest peak is here, or slightly positive skew. That's why when you do research, when you collect the data, you must take as many data as you can, so that your tabulation, the distribution is very nice, very obvious, where you can get this pattern, something like this, very good, or the best is like this. If you just take 50 to 100 data, or anything less, you won't be able to get a very nice pattern of the distribution. And from there, it's very hard for you to comment on the skewness. Okay, everyone. So that one is your future when you do your survey or you involve in the project and so on. Then you will come back to this skewness. It's one of the very important aspects when you want to analyze your data. Okay, so finish about histogram. You can do your tutorial after this. Now the next graph I want to discuss with you is called CF, cumulative frequency distribution, or the other word called OGF. Okay, what's OGF? OGF is actually cumulative frequency, can be derived by the addition. Addition means you sum, total up frequency of the successive classes. That means the first class you don't totally leave it there, but when you go to second class, you add the frequency before and to the respective classes frequency. So when you go to the next one, add again, add one by one until the last frequency. So there are two types of CF. One is called less than, and the other one is called more than. In this course, less than will be used. So for this subject, we will prefer to use less than now. But in actual fact, a person who wants to study comprehensive statistics, they must learn both less than and more than. So let me explain to you first. When a person learn how to draw OGF, or we call it CF curve, the first thing is they must learn how to add the frequency. Very simple, just add it up. Okay, now I'm showing you, go back to the same example for the books. Remember this books example? This one, where's our book? This one, the library one. Take back the same classes, take back the same frequency. Okay, we always use back the same example, easier to compare. All right, so this is your frequency. Now, I show you what's called less than. So class boundary, when you find the cumulative frequency table, okay, we use this less than symbol. Less than means this symbol. More than means we use more than. Okay, but let's concentrate on less than. So After you have the class limit here, this is your frequency, this is your class boundary. Remember, you need to plus minus 0.5 class boundary, close the gap. Then you take this upper, remember this side is all your upper, this is your lower, right? So you take the upper one, not the lower one, and then you put into here, you see the arrow, put into this another small box here. So this is what you're going to do, everybody listen carefully. When you do your tutorial later on, you have the class limit, you have the frequency, right? Then the class boundary depends on whether you need to close the gap or continuous. You don't need to close the gap, but you still write the class boundary. You take the upper one, put it here, you label it as a number of volts, and then your right hand side, this is your cumulative frequency. So what is cumulative frequency? It's the addition. So you see, the first one, 29.5, I bring to here. Listen carefully, everybody. This is your first class boundary, right? Take the upper one, move to here. So I add this sign. Add in less than symbol. A lot of people, they don't add in this one. So we are still wondering, we want to minus mark or not? Some people say not important. Otherwise, then why the word less than come in? So that's why we must put the sign less than, right? If you don't want to have this sign less than, then might as well there's no name called less than. Oh, so I believe it's important. So everyone add in this one. So 29.5. Okay, what's your frequency here? 8. Follow this one. The first one, 8. Okay, the next class boundary, 49.5. And then why your CF cumulative frequency is 15? Can someone tell me why 15 here? You plus what? Plus 7, Esther, correct. 8 plus 7 become 15. This is what we call addition of the successive classes. Everyone okay? Next, 69.5. Right here, you add the less than. So 15 plus 4 is what? 19. Next, 89.5. So what's your CF? Cumulative frequency, short form CF. Okay, 19 plus 7, 26. And the last class boundary, 109.5. Your CF is 26 plus 4 is 30. Everybody listen carefully. Your last CF here must be what? Same as the total frequency here. Remember the total here is 30 weeks. This one and this one must be same. If you don't get same here, means you add wrongly here, or somewhere your position is wrong. If your position is correct, you add accordingly, you should get 31. No issue, right? Then the next thing you will ask me, right? How come there is two extra thing one? You know what is this? Okay, can you copy down here? When draw or jive or cumulative frequency curve, we must start from 0. Where start from 0? from the CF. 0 start from the CF. So you see a CF here. Just now you start from 8, right? But you need to start from 0. Everybody, I highlight this here. Can I use this to highlight? Oh, cannot see it, sorry. I shouldn't have highlighted that. Okay lah, you highlight yourself. Start from 0. From CF. So your 8 here, not your first start. You must start from 0. So this 0, you add in our self. Don't forget to add in. So when you start from 0, you add in 0. Then your number of books, you must add in also. So why you add in 9.5 here? Can someone tell me why 9.5? Not 10.5 or 0? Why I choose 9.5? Can someone tell me when you add in 0 here, CF, why this is 9.5? Kim Sen say 9.5 because upper boundary. Lowest boundary, make it. If lowest boundary, what does that mean? Why not 10.5? Why not 0.5? Why not negative? Because if you look at this class boundary, do you see this is 20, 20, 20? So the first class, when you add in, can you tell me from where to where? It's 89.5, 89.5, 69, 69, 49, 49, 29, 29. So this 9.5, this one should be 9.5 lor. Yes or no? So what's your lower? If I want to know lower, what's your lower here? 20, 20, 20 the size. So this one is what?
Negative 19.5.
Negative 10.5. Negative 10.5. How I know? Minus 20, minus 20, minus 20, minus 20, minus 20. Negative 10.5 lah. Not correct. Oh, Ho Chi Chin correct. Yongket correct. I hope everyone know how to play with this lower, upper boundary, class size and so on. If you want to check 9.5 minus 10.5, the class size is also 20 ma. Remember the open-ended one must know which to which all. But anyway, what we want is the class boundary. So I will bring this 9.5 to here. So you add in this one also. You want to see you add in this, you want to see you add in 0, must start from 0. If you don't start from 0, we are going to chase after you. When you draw the object, you must start from 0. Anybody don't copy this? From the CF, any questions? So first thing, check same 30. Second thing, make sure you tally the CF, pass accordingly, and you must start from 0. So you need to add one more class size, one class boundary with the upper in your, we call this number of books, or we call it the class boundary. Okay. So this is for books where you have to close the gap, plus minus 1. This is the discrete one. Now, we are going to look at one example for, again, we use the rainfall. This is for the continuous. You see or not, we use back the same example, always the book and the rainfall. Okay, easier for you to remember. So the rainfall, remember the first class is 90 to 22, 22 to 25, and so on. The class size is 333, right? So this is the frequency. What's the total frequency here? 31. So your class boundary, no gap. Remember, you can throw away the less than, so 90 to 22, 20 to 25, and so on. This is your class limit. And your class boundary is the same. Okay, so when you want to draw the object, do the same. So either it's discrete or continuous. Never mind one. You draw the same box. We want to see this box. You must show this box. This box got marks 1. Okay. The rest is not so particular. Of course, you need to know this to bring in the upper boundary and the CF mark. But the marks will be mainly on this table and this one. Okay. Whether it's a discrete or continuous. So how to build this table for rainfall? Again, you look at the upper boundary, this side. So 22, the first one. Add in the symbol. So 4. Next, less than 25. 4 plus that is 14. Next class upper, 28. So 14 plus 12 is 26. The next upper, 31. Here, you see, 26 plus 4 is 30. And finally, 34. Less than 34. 30 plus 1 is 31. Must be same. And then what they say, your CF must start from 0, not 4. So you add in 0 here. Then, what do you add? Here, there's another class boundary. So can you tell me from where to where? 31, 28, 25, 22, 19. So this one should be what? Minus 3, 3, 3, 3, 16. 16, right? So this one 19, no? You bring in. So you need to add in this one. Add in 19, then add in 0. So when we draw the object, even later we draw the object, we follow this class boundary and follow this as a CF. Whether it's a continuous or discrete. Can? Alright, now we are going to draw one comprehensive example. You want to take a small break, 5 minutes break? Is it okay, everyone?
Okay.
Okay, 5 minutes break. See you later.